In the last video, we talked about the bare essentials of GDB. Using this, you can still get around in GDB, but it still doesn't do a whole lot more for you than printfs. To review, what you have to do when you're using GDB is compile with -G or -G3 in order to get the debugging symbols. When you want to actually see your source code, you can say list followed by a line or function number, or just say list to do the lines around where you currently are. R will run your code. B will add a breakpoint. You can optionally specify a file, just like you can in list. And to do that, you would say the name of the file, followed by a colon, and then you would say the line or the function in that file. To move one line down after you've started running, you say N for next. To continue on to the next breakpoint that you have, or until the end of the program, you say C. If you are stopped and you want to print out something, you can say P. And if you want to print out something every time you're stopped, you can say disp for display. Once you're done, you can say Q for quit. Now, let's jump into new stuff. Let's run GDB with the basic 2 test. This resolves the bug that we had in basic earlier. Here, you can see that it still has another bug. Last time when we figured out where the bug was, we did that by manually looking through the code to see where it printed this stuff out. A much easier way to figure out where your bug is once you get a seg fault is to use backtrace, or BT for short. When you say BT, it says that the bug happened in strlen, in VF in printf, which was called from our code in print combined array at segfault.c, line 50. Now we know exactly where the error was so that we can set a breakpoint there, or basically narrow down our debugging attention. If we want to actually go up to that stack frame, then we can say up 3 to go from the stack frame 0 up 1, 2, 3 to stack frame 3, which will take us into print combined array. And you can see now we are inside the stack frame of print combined array. Keep in mind that this doesn't back up execution of the program or anything like that. All it does is take you back there so that you can look at variables. What that means is that I can do things like pi to print the variable I, or I can print rsize to print out what array size is if you couldn't notice what it was up here. And you can generally look around at the state of the program from when your program crashed. And all things that go up must come down. So while there is an up command, there is also a down command. Down will bring you down 1 stack frame, or now that we're on stack frame 2, if we say down 2, it'll bring us back down to 0. And you can use up and down to navigate between the stack frames that you're on. So let's say that we didn't know that the issue was there, so we had accidentally set a breakpoint in main, just like in last time, in addition to setting a breakpoint in GDB Basics 2 after we had found out what the problem was. So now we have 2 breakpoints there. What that means is that if I run the program, it's going to stop at the main breakpoint before I continue and go on to GDB Basics 2. That gets pretty annoying if you're debugging a program for a long time and you end up having a lot of breakpoints. In order to manage your breakpoints, you can enable, disable, and delete breakpoints. If you say info breakpoints, that'll tell you all of the breakpoints that you have and how often they've been hit. If I want to get rid of breakpoint 1, then I can say disable 1, or disa1 for short. Then if I say info breakpoints, you can see enabled is set to no for breakpoint 1, which was in main at segfault.c line 144. That means that if I run again, it won't stop me at main, it'll just go directly to breakpoint 2. If I want to completely delete the breakpoint, you can say delete 1, and that'll delete breakpoint 1. Then if I say info breakpoints, it will only display breakpoint 2. Breakpoints aren't the only thing that you can get information about. If you say info, it'll tell you all of the different things you can get information about. A few useful things that you can do are info args, which will display all of the arguments that you have info functions or info files to display information about all of the function names or about all of the files that are being debugged, info locals for all local variables, info macro for getting the definition of what a particular macro is, info registers if you're doing assembly stuff and you want to figure out what the registers are, info threads if you're debugging a program that has multiple threads and you want to figure out what the number is of each thread according to GDB, info variables if you want to figure out what your global variables are. Now let's learn a little bit more about movement. We're in GDB Basics 2, and you can see we make an array, we print array, and this function is the working version of the same function that we had from last time. Then there are a few more functions. So when I say next, it'll go over line 78. If I say next again, it'll go over line 79, and it'll print out everything that was in line 79. But the bug is in print combined array. If I say next, it's just going to segfault. So it segfaults now. If I don't want to set a breakpoint inside of print combined array, because I'm already debugging it, I don't want to have to set a new breakpoint every time I want to go inside a new function, you can just press step, S for step. That steps into a given function. And you can see now I went from line 80, which was in GDB Basics 2, to now where I'm in line 48. And as you see here, if you say list with no arguments, that will print a continuation of whatever the previous list was. So I would have to say list 48 to get where I am now. Thus, because we used S, we could step inside of the current function. Now that I'm on line 48, let's say that I want to go next a few times in order to get to the place where it segfaults. I could just say n, 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 but instead of that, I could say n space 4, and it would execute next 4 times. So you can see I went from being on line 48 to next once, next twice, next 3 times, next 4 times. And so now I'm on line 49. You can do this with most movement commands, but it's generally something that you can get away without memorizing, because you can just hit next, 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 next. Instead of repeating a movement a certain number of times, you can just keep on going and resume until you hit a given line. This is basically like setting a breakpoint, because a breakpoint will stop you once you hit a given line, except for you don't have to deal with having another breakpoint. You just make it, and then it goes directly to that line. So if I say until 50, then that will go until I get to line 50. If I hit enter, then it'll go until I hit line 50 again. If you want to go until you finish the current function, instead of saying until finish or something like that, you just say finish. And that will keep going until you exit from the current stack frame. That's about all that we're going to do with the basic test. Let's go on to the movement test now. And apparently I called the movement test jump because this tests the jumpy movement. So let's run jump. You can see that this test is about to loop forever, and if we want to regain control of GDB, we have to use Control-C. I just press Control-C there, and you can see that I regained control of GDB. This is most useful when you are doing something like multiple threads and you have deadlock, because if you have deadlock, then you probably don't know where you got deadlock, because otherwise you could have fixed it, and because you have it, you cannot execute GDB commands because you're not at a GDB prompt. If you want to get to a GDB prompt when something is running, then you just have to hit Control-C, and it won't close your program, it'll just get you back to the GDB prompt. You can also use this if you're doing something that takes a long time, or maybe you just had like a sleep 100 or something like that, and you want to stop in the middle of it to regain control to print out some variable in the middle. For instance, if you have a really big machine learning program and you don't want your program to stop in the middle, but the program runs for a long, long time and you might want to let it run for 2 hours before printing out the values of variables, then you could just let it run and then interrupt it by pressing Control-C and then printing out the variables exactly when you want it. Now, when we get into an infinite loop or some place where we don't want to be, one way to get out is to just kill the program that we're debugging. To do that, you just say kill. And then if you say run again, you can start it again. Let's say that we don't want to kill it, but we actually want to get out of this test. So let's list to see what this test is. You can see that this is the return test, and the comment right above here will say that we can use GDB's, this should say, return command to get out of the infinite loop. What return does is pretty much the same as finish, except for it doesn't execute every line of code in between now and the end. In other words, if I say return, and then say yes, make return test return now, it will get out of that function, it will get out of return test, even though there's an infinite loop here, so it would be impossible to get out of this function normally. You can use the return command whenever you want to get out of something immediately. It just forces the function to return immediately without executing any more lines of code. Let's list where we are right now. You can see that we're on the jump test, so let's step into that test. So what this does is it prints that it's about to dereference null, then it dereferences null, which will cause a seg fault, and then at the very end, there's a success message. Now, if we just said return, we wouldn't get to this success message. So we don't want to just return, we actually want to go to line 114. To do that, we can use jump 114. And then you can see it will jump us to there and then continue execution. So it printed out success no seg fault, even though without using GDB there would be no way to get to that line. One word of caution about jump is that jump will bring you to whatever line of code you tell it to go to, which means that it doesn't do anything to get you to that line of code. It just tells your program, wait, I am here. What that means is that if you try to jump to some other function, then your program will not be correctly set up to deal with that other function. All of your registers will be messed up, all of the stack will be messed up, all of the local variables will be messed up. So probably you will only be using jump within a given function to get past a buggy line of code that isn't really essential for the functioning of your program. Now let's do some advanced printing features. So let's run the print test. You can see that this seg faults. Let's figure out where we were with a backtrace. So the function was print and examine. So let's set a breakpoint there. And run again. Let's see where we are. So print and examine is just a function that has a bunch of variables for us to play around with. The most basic use of print is by just saying print and then some variable. And you can see that because we are on line 136 and we have not executed line 136, this is just some random uninitialized garbage now. So go next, and now x should be initialized. So now you can see x is 99. Print, however, can do anything. So if we want to print out whatever the value of x is, we can say print x. But if we want to print out more a question about x, we can say print x double equals 99, and that will evaluate to true. If we say print x equals 999, that'll be false. If we want to interpret x as a character, we can say print /c x, and then that'll print that If x were a character, it would be the character c, because c has the value 99. If we want to print the address of x, we can print address of x, and then that'll give us the address of x. If we want to do a typecast to a character, for instance, we can say print character x. Let's go down a line or two. So now, if we say info locals, we can see the local variables that we have are x, x pointer, and string. X pointer should be the address of x, so let's verify that it is. Print address of x double equals x pointer. And yes, in fact, it is. We can dereference x pointer, so print the value at x pointer, and then that prints x. We can also print string, and then since it knows that the type is a car star, it'll print it as a car star. But if we want to instead print string 0, then that'll just print the h. And when I say that print can do anything, I don't just mean that print can print out any value. I really mean you can execute arbitrary code inside of print. So for instance, if I have a given function that I want to execute, for instance, if I want to execute the infinitely looping function called return test, then I can say p return test, and then it will execute that function as if I just typed that function line into my source code, compiled it at the exact location that I am currently at. So now if we want to get out of here, we'll do the same thing that we did before. So we'll Control-C to get back to GDB, and we will return, actually let's print up a backtrace to figure out where we are. So we are in return test, and that was called within GDB. So it says function called from GDB. So let's return from that. And now if we do a backtrace, you can see that we're right back where we were before. In addition to being able to run arbitrary functions, we can also set variables equal to stuff. So if we say info locals again, right now you can see x is 99. If I p x equals 5, then now you can see info locals, x is equal to 5. If I print the value at x pointer, then that will print out 5. If I print x, it'll print 5. If I execute my next line of code by saying next, it will print out that the integer value of x is 5. If you want to change pieces of your program at runtime or call functions at runtime, you can do all of that from within GDB. This is very useful for calling debug printing messages. For instance, if you want to print out everything that's in some linked list, that could be annoying to do from within GDB, but it would be pretty simple to write a function that would print out everything in a list. Then you could call that printing function from within GDB. It's also useful if you discover what a bug is while you're debugging, but you want to see if that's the only bug, then you could fix the bug by assigning some buggy value to some other value, and then continuing your execution from there. In addition to print, there is X, which stands for examine. If you X something, then that will basically do a pointer dereference and print out the thing that it's pointing to. So if I print out X pointer, then that will print out that the thing that X pointer is pointing to is a 5. If I examine string, then it says the thing that string is pointing to is an H. That's because it only looks at it as a character. In other words, X only looks at the thing that is directly being pointed to. You can augment this a little bit by telling it exactly what you want it to examine. All of the things that I'm about to show you are options that print can use also. For instance, if I want to examine the integer x, but say that it's a character, then I could say x/c, x pointer. And because it's 5, that isn't really anything meaningful. Let's set it back to 99. So now it looks like a C. If I want to examine it as an assembly instruction, then I can say \i. This is mostly used when you're actually debugging assembly and you want to examine something like the instruction that's at main plus 5 or the instruction that is in your current function plus 5. And to do that, you could say something like x print and examine, which would say that the very first thing is a push command. But all of this is really annoying if we had to just print out one thing at a time. In order to fix that, you can say x/10i print and examine, which will print out 10 assembly instructions starting at print and examine. Or for instance, if we wanted to print out the string, 10 characters of the string, we could say x\10c string. And you can see HELLO, WOR, etc. Of course, there is a way to just print it out as a string explicitly, where I can just say x\s string, and that will print out the whole string. And if you want to print out an integer value, or interpret something as an integer value, then the way to do that isn't by saying I, because that's for assembly instruction. Instead, it's D for digit. So x\d x pointer will examine x pointer as if it were pointing to a digit. And it is. It's pointing to 99. That's most of what there is to know about printing. Let's go into watch points now. So let's run the watch test. So you can see there's a string that should not be overwritten, and it looks like that string was, in fact, overwritten, unfortunately. Let's see where that test was, and what it was called. So that test was called watch points. Let's set a breakpoint in watch points. So we have good string, and that's the string that we want to print out at the end. What happens is we print good string, then we change this array, the array ARR, and then we print good string array again. Good string isn't inside of ARR, and we don't pass a pointer to good string, so set ARR shouldn't be able to change it. But apparently it is, because this printf is printing the mwahaha line instead of the this string should not be overwritten. To find out exactly where the error is happening, we can say watch good string. That sets a hardware watch point on a given variable, which means that any time that variable's value changes, then it will stop, as if you had set a breakpoint at that line. Let's continue. Here you can see the old value is 0, and that was actually only because we were on line 99 and had not yet executed line 99. So the value of the pointer was 0. Let's actually go back again to see what would normally happen. So now if I set the watch point after the value has already been initialized, I am now watching good string, and I continue. So it prints out the old value of the thing that was being watched, which was this string should not be overwritten, and it prints out the new value, mwahaha, I overwrite all, and it stops you when that value is overwritten. And so it looks like the value is overwritten in set array, line 91, when I is equal to 7. And you can see this is exactly the same error that we had before with the old print array function, that this is less than or equal to instead of less than. And we found that by setting a watch point on the value that shouldn't have changed. So whenever you have a value that is changing and it shouldn't, you can set a watch point on it to tell GDB to stop the program whenever that value changes. A few last things to help you out with GDB. You can actually run shell commands from within GDB. So for instance, if I type make, then it will run make. So right now, segfault hasn't been changed, but if I had another editor window open and I was editing segfault.c, then I could run make from within GDB instead of having to close out of GDB to run make. If I want to execute an arbitrary shell command, you actually can do that using the shell command. So if I want to list all the files in the current directory, then I can say shell ls. And that prints out all the files in the current directory. If I just want to get a shell, then I can just say shell, and then it will bring up a new shell on top of GDB. And then if I exit out of this shell, it'll take me back into GDB, right where I was before. And the last essential thing to know about GDB is that there is, in fact, help from within GDB. If you say help, it'll type you help. It'll say all the things that you can say help about. If you say help all, it'll list all of the commands that you can ask for help on, and there are a lot of commands because GDB is a pretty big program. If you ask for help on a particular command, it can give you that. So if you say help C, then it'll say that C continues the program being debugged after a signal or breakpoint. Now this is pretty much everything that you need to know for the essentials of GDB. Let's review all the things that we talked about in this video. We continue to use and to leverage all the things that we learned in the previous video. So for instance, we run with R. You can list a particular line or the current line or a function in order to figure out what that function does. You can set a breakpoint, or just B for short. You can say N for next, which will go one line down. You can say P for print. And we learned that print can execute any arbitrary code, and that it's not just used for printing values. Last time we also talked about using disp to display something that is printed at every given time instance. You can use C to continue executing code after a breakpoint, and you can use Q to stop. This time we talked about using BT or backtrace, which will print out exactly where we were after we got a segfault, or really at any other point in time. So if we hit a breakpoint, we can say BT to get a backtrace of all of the stack frames when we were at that breakpoint. Once we are navigating through stack frames, if we want to print out variables in a different stack frame than the one we're currently in, we can say up or down, which will bring us one stack frame up or one stack frame down. This was an example of where we would use a number after a command. So if we say up 3, that will execute up 3 times. Or if we say down 2, that'll execute down 2 times, which means that we would go up 3 stack frames or down 2 stack frames. If we have breakpoints that we want to manage, then instead of just having to go through all of them and start running the program again when we want to get rid of our breakpoints, we can enable or disable or delete a given breakpoint in order to figure out what the breakpoints are, what number they are, so that we can pass in the correct number to enable, disable, or delete. We can say info breakpoints. And there's also a ton of other really useful info commands that you can use. And in order to remind yourself of what all of those commands are, you can just type info and it will give you a list of all of the things you can get information about. Things like arguments, local variables, threads, registers, and plenty more. We learned about some more advanced ways to move. So in addition to N, which goes over one line, we can use S, which will step into a given line of code. We can say until to keep going until a given line of code, which functions pretty similar to setting a breakpoint somewhere and then hitting continue. You can say finish, which will finish executing a given function, and it will execute all of the code until it gets to the end of that function. There are also movement commands that just move your instruction pointer. In other words, they just move where you are in the code. They don't execute all of the lines between where you are and where you want to be. And these commands are return and jump. in addition to talking about how P can print any arbitrary line of code and can execute that line of code, we talked about how we can use X to examine the status of a pointer. And you can also say slash and then give it something that you want to examine it as, and even give a number of things that you want to examine it as in order to examine something as that thing. So for instance, if you want to examine 10 lines of assembly starting at main, you would say x/10i main. But instead of 10, you can give any number, or you can leave that out completely to just do 1. Instead of I, you could also do D for digit, or S for string, or C for character. And instead of main, you could do any pointer. So main is just a function pointer, but if you had a pointer to an integer, then you could deal with that one also. We also learned about using watch points, which will stop execution when the thing that you are watching changes. If you want to run shell commands, such as make, you can just type make. Alternately, you can type shell, which will bring up a shell, or a shell followed by a shell command to execute that shell command. If you need to get help about a given command, you can just type help, and GDB will tell you everything that you want to know about that command. After this video, you should know all of the essentials of GDB, and this is what most people know about GDB. The future videos will be things that are either domain-specific, so looking specifically at GDB's features for dealing with assembly, or specific to debugging threads. And we'll also learn about some things that are generally useful, but that are not as well known or as essential. For instance, reversible debugging, which lets you rewind the execution to a particular point in time before some line happened.